I'm just going to speak loudly. We're going to now transition to a industry and higher ed discussion on the evolutions in spectrum and wireless and the real world impacts of those. So I'm pleased to welcome some additional great speakers to the stage. So I have this in a certain order, but I'm just going to do it in the order I see you. So Mark Lewellen, who's Spectrum Manager with Deere, John Deere, welcome Mark. Chris Szymanski, who leads the wireless efforts for Broadcom. Hey Chris, welcome, good to see you sir. And Monisha Ghosh, who is a professor in the electrical engineering department at the University of Notre Dame, focusing on wireless technologies and research, and former CTO, of the FCC. So their full bios are in the program. We're going to kind of dive in so that we can make best use of the time. So I'm going to just start with unlicensed spectrum. And again, we had this comment from NCTA Administrator Roth that the U.S. is the leader in Wi-Fi, as I just mentioned on the other fireside chat. And that was largely due to the opening of the 6 gigahertz band, how the U.S. has led the world there. But as I think about, and it was great to hear Robin saying that, well, we have this recent legislation focusing on licensed spectrum, that the administration is looking at how to make the other wireless technologies whole in terms of their needs, if you will. So, Chris, I think maybe I'll just start with you and ask, what has 6 gigahertz done? Since the FCC took that action in April of 2020.
Thanks, Dave. I would say Administrator Roth and Robin killed it. I mean, we really changed the overall discussion on what Wi-Fi is capable of. If you look about this convention, you'll see the vast majority of gadgets out there are 6 gigahertz Wi-Fi enabled, and we're bringing wired-like reliability. I think in the U.S. you're going to have over 300 million 6 gigahertz Wi-Fi devices shipped. Broadcom alone has shipped 500 million 6 gigahertz Wi-Fi chipsets, just one supplier. We're seeing rapid innovation and adoption in enterprises. I'm not aware of any Wi-Fi 7 access points that are going out in the U.S. or in North America that don't have a 6 gigahertz radio, the capacity that you have. And then you contrast that with other countries that haven't followed the U.S.'s lead. You look at Europe, where you have, in Western Europe, sort of the same sort of purchasing power parity, but adoption's 2 to 3x less than what we see in the U.S. And so you're seeing all of this innovation, all of this capacity here. You're not seeing it there. So now we have, 5 generations of Android-based smartphones, 3 generations of iPhones. Microsoft has deployed 5 generations, so it's pretty hard to find a user device that isn't 6 gigahertz equipped. So we're moving in the right direction, and it was interesting to me at the NCTA summit. You're hearing, some people say, well, we should go backwards. So here we're winning this race, and I don't know, we're winning this race. Why would we go backwards when we're enabling so much in the way of capability and capacity? I've never seen adoption like this. I think the CTIA has said that when a band is identified and auctioned, it typically takes 10 years to bring it to fruition. We brought the 6 gigahertz band to fruition. It is the Wi-Fi band where innovation is happening. It's the future, and that happened in 5 years. So it's really, changed the state of Wi-Fi.
Cool. And it had been, 2 decades or so since there had been a significant unlicensed allocation prior to 6, so it was time, for sure. So thank you, Chris. Mark, I'm gonna turn to another area where the U.S. is led, and that's in dynamic spectrum management. And I'm thinking about the 3.5 gigahertz CBRS band, where we've taken this 150 megahertz of prime midband. We've said, okay, it's federally held, but we're not going to clear the military. We're going to figure out ways to work around them. So you're going to introduce this spectrum access system and these sensors and cloud coordination and everything else. And CBRS has given rise to all sorts of interesting services. So, mobile services, you got traditional mobile operators, you've got, again, new entrants offering mobile services in CBRS, you've got fixed wireless, so the WISPs are doing a lot with CBRS in rural parts, connecting the unconnected, and then private wireless, which I'm going to be coming to you in a second. So private wireless is a huge use case and one of the areas where America is leading based on the CBRS band. And then finally, kind of neutral host services, which I think Deere is also doing some work in. So I just want to ask you, can you help the audience understand what is Deere doing with CBRS and P5G?
So thanks, Chris. Thanks, Dave. So in 2020, we bought 5 PALs at auction, and we're using that to support our manufacturing facilities, both in the U.S. and around the world. So I joke with people that it helps clean up the floors and ceilings, but it's really true. In the ceilings, it helps get rid of the drop routers that we used to have around millions of square feet of manufacturing facility. And although Wi-Fi is a great technology, it is not the best for that type of deployment. The private 5G LTE is much, much better. Cellular is not going to work in this environment. Why? Well, most of our manufacturing facilities are, one, out in rural areas, so there's probably not going to be a cell tower. If there is one, it's not going to penetrate our big metal buildings. So cellular is not the answer to providing connectivity on my factory floor. Private 5G LTE is. It's much better for that use case. We love it. We're big users. We want to use it more. We want to expand.
Great. And you were noting that the macro tower outdoors is not suitable for your uses indoors. I'm also thinking about, I know some of the other drivers around private networks can be data security and privacy. Was that a concern for you all as you thought about deploying your own network instead of using an
So
operator?
it's got a lot of features that you don't get with Wi-Fi, for example. So with Wi-Fi, there's no roaming. There's no priority and preemptive access. There's no, like I said, security. So just being able to control the access to that network and being able to know who's on it and who's not is just a lot better from an enterprise point of view. We also have data that travels on that private network that will never, ever touch a public network because it's too proprietary. So being able to use that network ourselves, being able to design it, being able to put coverage where we want it, both indoors as well as outdoors around our facilities, is fantastic.
Great. Thank you. So again, I would contend that the U.S. is leading in dynamic spectrum management. We've done that with CBRS, the SAS, the ESC networks. We've also done it in 6 gigahertz unlicensed. For those of you who aren't familiar, that one of the modes, if you will, of accessing 6 gigahertz is standard power. Standard power also uses a cloud database coordination system called the AFC, or Automated Frequency Coordination. So Monisha, I was going to ask you, as we think about what we've seen in CBRS, what we've seen 6 gigahertz AFC, what are some of the lessons we've learned about this dynamic spectrum stuff, and how do we apply it going forward? Can we indeed make better use of the pie or satisfy more appetites from this pie using dynamic spectrum sharing technologies? What do you think? And the role of AI, ML, whatever you'd like to talk about there.
Sure, thanks. I think it bears emphasizing once again that both of these examples you just heard about, 6 gigahertz and CBRS, are shared bands. Yes, 6 gigahertz is unlicensed shared band, CBRS is licensed by rule, but they're shared bands. And there is a huge advantage that comes with sharing in the sense that you don't have to clear out any of the incumbents, you don't have to pay and wait for them to vacate the space. You could just layer on another use cases on that same band. So I'd like to think about it as, in New York City, where real estate is very expensive, we don't build single-family homes. We go upwards. We layer on floors as we need more space for people. It's the same thing with spectrum. If we are intelligent about it, we can have Navy radars operate in the same band as CBRS. We can have fixed links operate in the same band as unlicensed. without the troubles of moving everything out. The lessons that we've learned, I think, is that this just works. Can they be done better? Yes. So let me point out one area where actually CBRS has improved over the years. One of the key things when you're doing database sharing is a good propagation model, because that is what determines how much interference you're going to create to the incumbent, right? Now, when we start off in a new band, we don't have all the measurements that we need. We kind of make assumptions based on past similar bands, based on studies, based on limited measurements, and oftentimes it can be a bit conservative. And that's actually what happened in CBRS. The initial propagation models were over-conservative, and one way of looking at it is that no incumbent, which is the Navy radar, has ever complained of interference. So what happened over the last year is that as more measurements were made, you could improve the propagation model, and it was really easy because none of the devices had to change. All you had to change was the model you used in your cloud platform, and then suddenly more devices got access to the band than they did before. So there is a lot to be learned about how to do these database sharing methodologies. The criticism for CBRS has been that it's not dynamic enough, which is true. It takes a while for a channel to be allocated. It's very dynamic when it comes to vacating the spectrum if there is an incumbent, so that's never been a problem. And so there are bodies like the Wireless Innovation Forum, the WIN Forum, that develop the standards for CBRS, as well as the AFC for 6 gigahertz, that is continuing to work on refining these ways that we do spectrum sharing. We are looking at highly dynamic spectrum sharing, which is, can you really use spectrum at a very, very granular level if you can sense better? On the other extreme, you take a building like this. This is like a Faraday cage. There's very little coming in, there's very little leaking out. So can we not use some of the natural containment capabilities that buildings provide to get more access to things like warehouses where you need spectrum? So I think if you look at the amount of spectrum that we have in unlicensed as well as licensed, and you compare that with the amount we have in the shared spectrum, it's really lagging behind. We just have 150 megahertz of CBRS type shared spectrum. And talking of American innovation, we talk a lot about 6 gigahertz. I think CBRS is a true American innovation. And many, many countries have actually, even though they didn't have Navy radars, they glommed onto the concept that you can have a band where you're not transmitting at very high power, but because you're transmitting at low or medium power, you can share that band better. And this has been the rationale for, say, Ofcom using 3.8 to 4.2 gigahertz on a shared basis to do exactly the kind of applications that are being done in CBRS in the US. That's another great example of US innovation.
Thank you. Yeah, and it's starting to be, the U.S. led, other countries are following. The good news is if you look at reports from the Global Mobile Suppliers Association, which is Ericsson, Nokia, and all the handset manufacturers, all the people who supply cellular equipment, they say the U.S. is far and away in the lead on private networks, and it's due to CBRS. Other countries are following the lead, but we're still way out in front because anybody can deploy a CBRS network. The barriers to entry are pretty much non-existent. Real quick, you talked about, CBRS is a U.S. success. Couldn't agree more. Unfortunately, it will only ever be a U.S.-specific solution just because it's sort of tailored to that frequency range in the U.S. One of the things I'm excited about with the 6 gigahertz AFC is the fact that it's not U.S.-specific. So I don't know, Chris, do you want to tell us about what's happening there? Because I think it could take dynamic spectrum sharing global.
Yeah, sure, Dave. So about 4 years ago, Broadcom partnered with Meta and Cisco to create the Open AFC software project under the Telecom Infrastructure Project. And then recently, we created a group that incorporated Cable Labs and the Wi-Fi Alliance. And we're acting as trustees for this code. And basically what we've done is we've created an open and scalable platform that can be modified country by country. So I've given this code to the UK government, we've given it to the Brazilian government. It scales. So it's basically containerized. You don't have to be a software maven to develop all kinds of new code. And it can be easily modified for each and every country's parameters. That makes it easy. At least from a Broadcom perspective, we don't care who's enabling the AFC. We just want the equipment that we've built to operate and perform the way we've built it to perform, and we need global scale. So we see countries around the world moving. You know, South Korea's thinking about this, Japan's thinking about this, Saudi Arabia has opened up a rulemaking. And so it's taken a little bit of time for the world to catch on to AFC because it's complex. It's far more complex than traditional Wi-Fi, but in the US, the market has absorbed it. So I'm looking in stadiums, you know, Monisha has been testing Notre Dame. I checked out the Honda Center, and it's flawless. Flawless, very easy to roam off and on. As a user, you have no idea the complexity that's happening in the back end. It scales, and if someone complains about an interference event, it can go away like this. So eventually, we can be a little bit more aggressive in the policy and enable a little bit more robust use and enable all kinds of new use cases.
Great. I think it's amazing how we're enabling, you know, higher power Wi-Fi, still lower power than cellular, but higher power Wi-Fi while protecting the incumbent fixed links using this database coordination. I mean, that's, and again, now that's trickling out around the world. So I think over time it's going to become the global default. And all of the standards around this, the protocol interfaces, they were developed here in the U.S., mostly by U.S. engineers. So again, American innovation, American leadership. Mark, you talked about Deere's use of CBRS for private 5G, manufacturing, what you're doing on, again, in your assembly areas and whatnot. You shared with me that you also use some of the spectrum for neutral host services. Can you explain what that means in a Deere context?
Great question. So at Deere, we made a decision that even though we've got these metal buildings, right, we want you to be able to connect with your own personal cell phone while you're at work. Not just your Deere phone, but your own personal phone. So the CBRS band is 150 megahertz. We've dedicated 60 of that to the 3 carriers, so that T-Mobile, Verizon, and AT&T all have 20 megahertz each indoors at our facilities that you can connect. The neutral host then takes that and translates it into their public spectrum and connects it to their public network. So all of your phones can work inside of our metal buildings. And I believe that we're the first industrial company to do that and be able to talk about it.
Thank you. No, that's great.
Can I add to that?
Please.
Yeah. So we have done actually a lot of measurements on neutral hosts, and we've quantified the improvement. We've quantified how much throughput improvements you get when you're trying to connect to a CBSD inside a building rather than to a macro network outside. The throughput improvements sometimes can be 10x. Your mobile now conserves a lot more power because you're not trying to transmit a high enough power to overcome the 20 dB loss that you have to go through when you're trying to reach a macro outside the building versus reaching a CBSD inside the building. So I think there are real use cases, and the question I get asked a lot is it going to replace Wi-Fi? I say no. They're completely different complementary networks that are doing different things. There are many things that the quality of service that a 3GPP system allows you to do is needed, and there are other times when Wi-Fi is just fine. So having the ability to implement either a cellular network or a Wi-Fi network on your premises under your own control is a huge boon to enterprises. It's really amazing what you can do with it.
Great.
Dave, I'll just add on to that a little bit. CBRS and Wi-Fi share one really key factor. The base station is close to the user. So Robin was talking about earlier, what is it going to take to bring about AI to the masses? You're not going to do that with macro cellular base stations. Do a speed test in here, do a speed test at your home, do a speed test anywhere. The uplink is going to have a much higher latency and jitter in a macro wireless network than you'll have with a local area network. So if we're talking about next generation services, you're going to need the sort of densification that these two types of deployments are going to provide.
You're front running me now, but that's okay. Chris is leading me into my next question. But before I go there, I'm just going to make the observation that as we talk about this neutral host capability of CBRS, it's also important to keep in mind it's not mutually exclusive. You don't have to deploy a network. Deere didn't deploy a network and say it's a neutral host network or it's a private 5G network. It's both, right? They're using some of the capacity for their internal communications needs in a private context, and then they're using it to connect the subscribers of the big three mobile operators in a neutral host, and they've got it all in one solution. It's really cool. So going where Chris was leading us, as we talk about unlicensed Wi-Fi and CBRS, they're both lower power wireless technologies. So CBRS operates at 1 watts indoors, up to 50 watts outdoors. Wi-Fi can operate at various power levels, but it kind of taps out at about 4 watts, let's call it, in most cases, and that's sort of outdoors, typically for factory coverage. A lot of it's at 1 watt or less. So I want to explore the densification point that you just kind of alluded to, Chris, in the context of lower power, because there are people advocating for CBRS higher power for one thing, and one of the contentions I would make is that's going to make much less efficient use of the spectrum because we won't be able to deploy nearly as densely as we have. So I don't know who wants to jump in on that, but the relationship between power levels and densification, and yeah, Monisha?
Yeah, that's absolutely true. I mean, sharing, densification, all of these work much better with lower power. It's like, if you think about this room, there are many conversations happening here, and they're all being supported because everybody is talking at reasonable levels, right? If somebody were to go with a megaphone and stand over there, all these other conversations would disappear. So it's the same thing with shared spectrum as well. If everybody, sharing just works better when you have low and or medium power, or you use just the amount of power you need to close the link that you have to. You don't want to be in a situation where you're transmitting more power than you need to overcome things like building losses, right? That is just wasteful. It is not green. There's a lot of emphasis now on sustainable communications. So small cells, lower power, it actually gives you benefits on all counts. You get better coverage, you get better capacity, you get lower average power consumption.
Indoor intensification, Chris?
Yeah, I agree wholeheartedly with Dr. Ghosh, what was said there. At the end of the day, if you look at the densification requirements, and people compare us to China all the time, China, race to China, race. Well, their deployment model has probably about 10x more base stations per square kilometer than what you'd have, say, in Los Angeles or Chicago. So unless something is going to change vastly with the deployment of our telecommunications infrastructure, we've got to look at sort of how we're going to provide capability. And I really liked how the first Trump administration and then Chairman Pai looked at this. He looked at 5G fast, and he included Wi-Fi, included CBRS, he included cellular, because it's an all-of-the-above approach in order to provide connectivity where you want it, in the room, in the warehouse, outdoors. So I think that sort of approach is necessary, and then we'll have the densification we need, Dave.
Great. So you mentioned China's public cellular network density versus the U.S., and I brought this up at the symposium a few weeks ago myself, so I have some of those numbers fresh in my head, and yeah, there's 4.4 million in China Mobile, so just one of the big three in China has 4.4 million cell sites. The U.S. big three have approximately 250,000 traditional cell sites, and then estimated about 138,000 small cells, so 388 or 382, something like that. So it's actually 11x in China. And I know, Monisha, you've looked at some of the other countries, and we see this similar density disparity. And so I think about, people want to throw spectrum at this. Spectrum is always the answer. It's like, no, densify your network. That's a better answer. It doesn't require new spectrum.
Yeah, I think the numbers I've recently found is there's something called the 5G Observatory that the European Commission has. Anybody can go, you Google it, you'll find it. The numbers that jumped out at me on that was they had a number for 5G base stations per 100,000 people. South Korea has 670 base stations per 100,000. These are just 5G base stations. The US has 42, and China has 301, right? South Korea has less mid-band spectrum than the US. So clearly, and they have pretty much 100% 5G rural coverage. So if you want to connect all the dots together, if you really want 100% 5G coverage even in rural areas, it's not more spectrum that's going to give you that. It is a combination of spectrum, but more importantly, deployments. The beauty about CBRS and the neutral host model is it's not only shared spectrum, it's shared infrastructure too. So it is one network inside a building like this, which is being shared by 3 or more operators. The spectrum is being shared by 3 or more operators. And it is not sustainable to keep going forward with the model where you have, everybody puts out their own deployment to cover a nation, and everybody has their own spectrum, which is not being used maybe in many places. So the CBRS is fluid. It's a use it or lose it thing. So even if somebody has a PAL license in an area and they haven't deployed, that band is not sitting idle. Somebody can use it with the GAA license until the PAL licensee deploys. So this ability to be able to optimally use the spectrum is, I think, really, really important, especially because the pie is not growing bigger. So we have to figure out how to use it better.
That's a great point. And not only is it the efficient sharing between those 3 operators, but again, you can use it for private uses as well. So there you go. And Wi-Fi really does the same thing, I would contend. If you're on the Wi-Fi network here, you're probably, if you placed a voice call, it would go over the Wi-Fi network using Wi-Fi calling, right? So we all use Wi-Fi calling now. That's a public service, and you're also using it for your internal, office connectivity as well. So it's the same metaphor, and yeah. Okay, where was I going to go next? We have a little bit of time left. So, Mark, Deere recently helped launch a new industry organization called the 5G OT Alliance. Can you tell us a little bit about what the OT Alliance is and what it's about?
Sure. Yeah, so 2 things. So one, we recently joined the OnGo Alliance, and one of my colleagues has recently voted on the board of directors to that. But in parallel, Deere, along with some other industry groups, have formed what you just mentioned, the 5G OT Alliance. This is specifically around the private 5G use case. So other people in the alliance are like Georgia Pacific, Cargill, Nutrien, Miami-Dade Airport, BASF, and a few other folks. So we're having our first face-to-face meeting in Miami in December, which I think will be a good thing. And we'll get a behind-the-scenes tour of the Miami-Dade Airport, which are big CBRS GAA users.
Yeah, Miami-Dade's been very active in the FCC proceeding about CBRS, talking about how they're using it on the ramps for aircraft inspections and logistics, as well as perimeter security around the runways and all sorts of interesting things. That sounds like it'll be a fun tour. Yep. Chris, I'm going to loop back to you. We've got about 2 minutes left here. So the U.S. opened 1,200 megahertz of unlicensed in 2020, and you told us about all the cool things that has enabled. So are you all set for spectrum needs?
Dave, I'm really glad you asked that question. No, we're not. We're actually at an inflection point right now. We're seeing massive adoption of 6 gigahertz, and we're seeing these channels fill up in all these stadiums, enterprises, etc. In Wi-Fi 7, we went to 320 megahertz channels. Wi-Fi 8 is right around the corner. Channel size remained the same. The large reason that the channel size remained the same is because there was insufficient spectrum to go larger. Broadcom would like to see 640 megahertz channels available for Wi-Fi 9. So if you stop right around the corner here, you'll see Charter has a demo that Broadcom's enabled and we can get you almost 9, 10 gigabits per second to the palm of your hands. We could have a whole home mesh network delivering 10 gigabit broadband. The innovation here is going to be great for the AI era. We're talking about incredibly low latency, uplink traffic, highly reliable networks. And so this is one of those rare, it's like wonderful Vegas odds. 125, nets you 640. All we need is a little bit of spectrum to enable this brand new use case, and we're already innovating. We're already able to show this. And so typically you need 4 channels to make a market. This would net us another 320 megahertz channel. And all of those devices that are out there could be software upgraded if the manufacturer chose to do so. So this is something that's relatively trivial from an engineering standpoint. At least our radios, Broadcom's radios, could be upgraded. And we could put all of that capacity in the hands of American businesses. So would really love to see that happen.
Sweet. I mentioned, we're going to do one last question, and I'll probably pose this to Mark and Monisha. So I mentioned that there are people advocating for higher power in CBRS, which I think would fundamentally change the nature of the band. And Mark, I'm just going to say, if CBRS as we know it, at the low power levels, if it goes up to macrocellular power levels and, PEA type coverage areas, what does that do to your solution?
It would be devastating. I mean, this private 5G for us has become almost, I can't think of the right word, indisposable in terms of an enterprise use case. We don't want to go back to cables on the floor, and we don't want to go back to drop Wi-Fi routers in the ceiling. We like Wi-Fi. We like Wi-Fi in the carpeted areas, but not for the manufacturing facilities.
Monisha, what are your thoughts?
Same thing. So South Bend, where Notre Dame is, the school district deployed a CBRS network to service underserved school children. Not because they didn't have other options, but because they were too expensive. We've studied that network intensively, and there's already, Verizon has deployed CBRS in that area. So there's a lot of co-channel use, co-channel interference we are already seeing at the current power levels. It's manageable at the power levels that we have now. If there were providers who came in with higher power levels, the co-channel interference that you would start seeing in these very dense areas would really wipe out the smaller players. The larger players would survive, but the school districts would not be able to survive with their low power network in the face of high power.
And there goes all the innovation that we've been talking about. So, okay. Well, we need to wrap there. I don't give time back, so we've used all of ours. But I just want to thank the three of you. This has been a great discussion. And please join me in thanking our panelists.